Now that we learned what classification means, let's talk about what it means to build a classification model and how building a model differs from applying a model. By the end of this video, you should be able to discuss what building a classification model means, explain the difference between building and applying a model, summarize why the parameters of a model need to be adjusted, describe the goal of a classification algorithm, and name some common algorithms for classification. A machine learning model is a mathematical model or a parametric function over the inputs. In the general sense, this means that the model has parameters and uses equations to determine the relationship between its inputs and outputs. The parameters are used by the model to modify the inputs to generate the outputs. The model adjusts its parameters in order to correct or refine this input-output relationship. Here is an example of a simple model. This mathematical model represents a line. Y is the output, X is the input, M determines the slope of the line, and B determines the y-intercept, or where the line crosses the y-axis. M and B are the model's parameters. Given a specific value for X, the model uses its parameters along with X to determine Y. By adjusting the values for parameters M and B, the model can adjust how the input X maps to the output Y. Here, we see how the output Y changes for the same value of input X when parameters B changed. Recall that B is the y-intercept, or where the line crosses the y-axis. The value of B is positive 1 for the red line and negative 1 for the blue line. For the input X equals 1, the value of Y is 3 for the red line, as indicated by the red arrow. For the blue line, when the parameter B changes from positive 1 to negative 1, for X equals 1, the value of Y is 1, as indicated by the blue arrow. So we see that with just a simple change in one model parameter, the input to output mapping changes. A machine learning model works in a very similar way. It maps input values to output values and adjusts its parameters in order to correct or refine this input-output mapping. The parameters of a machine learning model are adjusted or estimated from the data using a learning algorithm. This, in essence, is what's involved in building a model. This process is referred to by many terms as model building, model creation, model training, and model fitting. In building a model, we want to adjust the parameters in order to reduce the model's error. In the case of supervised tasks, such as classification, this means getting the model's outputs to match the targets or desired outputs as much as possible. Since the classification task is to predict the category or class given the input variables, you can think of the classification problem visually as carving up the input space into regions corresponding to different class labels. In this diagram, for example, the classification model needs to form the boundaries to define the regions separating red triangles from blue diamonds, from green circles, from yellow squares. In this example, if a sample falls within the region in the upper right corner, it will be classified as a blue diamond. Classification decisions are based on these regions, and the regions are defined by the boundaries, as indicated by the dashed lines in this diagram. Thus, these boundaries are referred to as decision boundaries. Building a classification model then means using the data to adjust the model's parameters in order to form decision boundaries to separate the target classes. Note that the term classifier is often used to mean classification model. In general, building a classification model, as well as other machine learning models, involves two phases. The first is the training phase, in which the model is constructed and its parameters adjusted using what's referred to as training data. Training data is the data set used to train or create the model. The second is the testing phase. This is where the learned model is applied to new data, that is, data not used in the training model. Here's another way to look at the two phases. In the training phase, the learning algorithm uses the training data to adjust the model's parameters to minimize errors. At the end of the training phase, you get the trained model. In the testing phase, the trained model is applied to test data, and test data is separate from the training data. Remember, training data is previously seen by the model, and the test data is not previously seen by the model. The model is then evaluated on how it performs on the test data. The goal in building a classifier model is to have the model perform well on training as well as test data. We will discuss in more detail the use of training and test when we discuss model evaluation. To summarize what we learned until this point, to adjust the model's parameters, we need to apply a learning algorithm. Now let's outline some commonly used algorithms for building a classification model. Recall that the classification task is to predict the category from the input variables. A classification model processes the input data it receives and provides an output. Since classification is a supervised task, a target or desired output is provided for each sample. The goal is to get the model outputs to match the targets as much as possible. A classification model adjusts its parameters to get its outputs to match the targets. To adjust a model's parameters, a learning algorithm is applied. This occurs in the training phase when the model is constructed. There are many algorithms to build a classification model, including KNN or K-nearest neighbors, decision trees, and naive Bayes. KNN stands for K-nearest neighbors. This technique relies on the notion that samples with similar characteristics, that is, samples with similar values for input, likely belong to the same class. So classification of a sample is dependent on the target values of the neighboring points. Another classification technique, which is very popular, is referred to as decision tree. A decision tree is a classification model that uses a tree-like structure to represent multiple decision paths. Traversing each path leads to a different way to classify an input sample. A naive Bayes model uses a probabilistic approach to classification. Bayes' theorem is used to capture the relationships between the input data and the output class. Simply put, the Bayes' theorem compares the probability of an event in the presence of another event. Here, we see the probability of A if B is present. An example for this is probability of having a fire if the weather is hot. You can imagine event B depending on more than one variable, e.g. weather is hot and windy. There are many other classification techniques, but we will now move on to decision trees as a form of classification algorithm to do weather classification in scikit-learn in Python. So let's review decision trees before we move on with our notebook.